Hey there, everybody. Welcome back. This is going to be 6.3. And here you can see we're talking about slope of a line. All right, so we were doing intercepts, but I'm going to just pick any 2 points on our line. Let's say this is point 2. And I'm going to label it x2 comma y2. And let's say this is point 1. And I'm going to label it x1 comma y1. The slope of a line measures the steepness. Okay. It measures the steepness of a line. It actually has a very specific value. And it's the same for no matter which 2 points you pick on a line. The slope of a line, we designate the letter M. I don't know why. I know we use S for arc length and trigonometry and stuff like that, but M is slope. And if I have 2 points, the equation to find the slope is y2 minus y1. And then we're going to divide by x2 minus x1. Okay. And it actually doesn't matter which point you labeled which, as long as you do them in the same order. I'll relabel this in green letters. I'm going to call this, I'll say this is point 1, x1 comma y1. And I'll say this is point 2 in green, x2 comma y2. So this was the slope with the red line. And this is the way we tend to memorize it. But I just want to show you that it doesn't matter which 2 we pick. If I do m equals let me call it, I'm going to call this 2b and this will be 1a because I want you to see that how they work up. So this will be y2b minus y1b over x2b minus x1b. If I just multiply by -1 over -1, this turns into y1b minus y2b over x1b minus x2b. But if we compare up the points, y2b is y1. Right there. y1b is y2. x2b is x1. And x1b was x2. So it doesn't matter which order you do them. That might be confusing. This is the important part to remember. Okay. So we say the slope is y2 minus y1 over x2 minus x1. This is the change in the y direction over the change in the x direction. We use triangles to represent change. That's the Greek symbol delta. And it means change in mathematics. And another way you might have heard it is rise over run. So for a line like this, The rise is how much it goes up, and the run is how much it goes to the right. Okay. Let's see. I'll do some, let's do some quick examples here. And then we're going to do slope-intercept form in another video. If I have like -2, -3, and 1, 3, I'll start off, I'll call this 0.1 and I'll call this 0.2. So that this is x1, this is y1, x2, y2. I'll show you what I mean by we can do it either way. So if I plug them in, y2 comes first, and that's the 3. Y1 comes second, is the -3. And it's the negative is different than the minus sign. And then I do x2 first, and then I do x1 second. This ends up being 3 plus 3, which is 6, over 1 plus 2, which is 3. I get m equals 2 when I do them in that order. If I switch the order and I call this x2, y2, and I call this x1, y1, the order on the equation changes where they go. Y2 is -3. This is y1, which is +3. X2 is -2 and x1 is -1. This is -3 or -6 over -3. We still get m equals 2 either way. That's what I mean by it's good either way. If you were to plot these, -2, -3 is down there, 1, 3 is up there. You will find slopes that go upwards from left to right. M is greater than 0 if the slope rises from left to right. Okay. Why don't you give it a try, you guys, with -3, 1 and 1, -2. Pause the video, figure out what the slope is, M. All right, I will assume you did. I'm going to call that 1 and 2. You may have chosen differently. If you did, you should still get the same slope. I like putting the fraction bar and the minus signs in right away. That way, when I'm plugging the numbers in, I don't confuse the minus sign here with the negative sign on the numbers. So x2, y2, x1, and y1. Y2 comes first, y1 comes second, x2 comes first, x1 comes second. I'm getting -3 over +4. If you did the other way around, you would have had 1 minus -2, -3 minus 1. You would have had 3 over -4. They're the same slope. It doesn't matter where the negative is. For both of these, m equals -3/4. But looking at it with the negative on top and the negative on bottom is actually helpful when you're graphing, as I'll show you in the next video when we're doing stuff with it. So -3, 1 is back here. And 1, -2 is there. Here, m was less than 0. M is less than 0 when the slope sinks from left to right. Two more sets will do. Negative 1 comma 4, 2 comma 4. I'll go with 1 and 2. Y2 is 4, Y1 is 4, X2 is 2, X1 is negative 1. I get 0 over 3, which is just 0. What does that mean? Positive slopes go up, negative slopes go down. As I go from positive to negative, I slowly, the less positive it gets closer to like this. And then as soon as it's negative, it's pointing downward. A slope of 0 makes a horizontal line, as you can see when you plot these points. It's helpful to think of it as a change in y equals 0, which means no up and down. Okay. And then if we see something like, oh, those don't look good. That's completely wrong. Let's do 5 comma 1 and 5 comma negative 2. Point 1, point 2. Y2 is negative 2, Y1 is 1. X2 is 5, X1 is 5. I get negative 3 over 0. This is my change in X. There is no change in X left and right. You'll see when we graph that, this makes a vertical line. When there's a 0 on the bottom, we say the slope is undefined. That'll be it for this first video. Peace.